In this presentation, we will uncover one of the biggest operational challenge inside a blast furnace, the cycle of hanging and sleeping. Let's see why these phenomena occur, how they impact the furnace stability, and metallurgical factors behind them. Now coming to the question, what is hanging? Hanging happens when breezes of partially molten ore form in the cohesive zone. These softened layers glue together, preventing the burden from flowing smoothly downward. Meanwhile, coke keeps burning below, creating dangerous void, or you can say empty space. So, what is sleeping? When these voids collapse, the burden suddenly falls. This is called a slip. Slipping disrupts the entire layer structure, disturbs gas flow, and leads to areas of poor prediction, poor reduction, and new breezes may then form again, trapping the furnace in a repeating cycle. So once one layer gets disturbed, it need again a one shift time to refresh it and to form a new layers. Coming to this slide, which is about a key operational causes, hanging and sleeping are closely tied to burden descent problem. High blast pressure difference called delta P process is a major figure. If it exceeds 1.6 to 2 bar, the furnace start becoming unstable with frequent slips and chills. Now coming to the hot furnace condition, a furnace that runs too hot also descend poorly with less weight above the melting zone and more slag held up. The downward driving force also reduces. This makes the body movement sluggish and the sluggish and increased risk of hang and sleep. Cast house in liquid level management is supposed to be very important aspects in such type of anomalous situation. A poor cast house operation can worsen the matter. Higher liquid level in hearth increases buoyancy, compressing the cohesive zone from below while it is already under charge weight from above. This reduces permeability and raises the gas pressure losses immensely. Insufficient gas reduction is also a add-on to the problems. If the ore burden is not properly pre-reduced before reaching the high temperature tier zone, it melts with too much oxygen still inside. This oxygen is removed by direct reduction, consuming coke and pushing the cohesive zone dangerously downward and even risking a chill if it goes very close to tear, and tear burning may also occur. Now over burden descent issue, besides hanging and sleeping, irregular descent can cause gas channeling, uneven gas path, fines concentration, poor slag drainage, escape at the wall, delayed charging, or mix ore coke layer all disturb uniform flow through the stack, and this leads a ununiform gas distribution across the stack. And finally, the root lies in material quality. Softening and permeability depend on slag composition. Ideally, burden material should soften and melt closer together at higher temperature. This keeps the cohesive zone compact and helps gases flow uniformly. That is the key to a stable blast furnace operation.